Section 7.4 is on solving rational equations. Now this is similar but different to the previous sections. Because these are actually equations, so you're going to see an equal sign, we actually will get a value for x. So our answer could be something like x is equal to 5. Whereas in the previous sections we were simplifying expressions and our answer could be very messy, like x squared minus 2 over x plus 7 or something like that. So here we're actually just going to get like a single number or potentially two numbers for x. Okay, so to solve we need to multiply each term by the LCD itself. Technically over 1. Not by what it needs to get the LCD. So in the last section when we were doing the complex rational expressions or the fractions inside of fractions, this was similar where we were multiplying by the LCD itself. In the section before that, we were multiplying by what we needed to get the LCD. I actually have a chart at the end of this section kind of highlighting the differences between these sections because they're very similar but they're also different. So it's going to be good to check out that chart to kind of see how do I know when I need to do what. But anyway, after that we need to simplify, then solve for x. And because we're dealing with fractions, meaning rational expressions, we have fractions. If your answer makes any of the original denominators 0, then you need to remove this answer. It needs to be thrown out because that would make it undefined. So always check your answer to make sure it's not making a denominator 0. And our process for finding the LCD is the same. Okay, so for number 1, I have 3 terms, and my LCD is going to be 5x. So I want to multiply each of these by 5x. And after I simplify, I should actually have no fractions left. So that's kind of a good check. So I have 7x minus 4 is equal to 9x minus 20. So the 9 and the x get multiplied, the 4 and the 5 get multiplied. And you'll notice that we no longer have any fractions, and this is just an equation. And we can solve this. So if you subtract 9x from both sides, this is what we get. If you add 4 to both sides, we get negative 16. And then if you divide both sides by negative 2, we get 8. Now if I check this in all of my denominators, 5 times 8 is 40, that's not 0. It doesn't even go into that one. And then 8 itself is 8, it's not 0. So it's not making any of my denominators 0. So this is our final answer.